everyone, welcome back to my channel. In today's video we are going to briefly discuss about some important points related to high school teachers recruitment. Okay, so this will be the class ninth science notes about the structure of atom chapter. Firstly, we are going to discuss with the subatomic particles like protons, electrons and neutrons. So electrons, this was discovered in a cathode ray experiment, and the term electron was coined by Gpstr. Protons were discovered in anode ray experiment, and anode rays are also called as Posey rays or the canal rays. So protons were discovered by William Wade in 1902, and it was identified by J.J. Thomson. Neutron, these were discovered by James Chadwick. Secondly, the atomic models. So there are various atomic models to explain the structure of atom. First and foremost, the model we are going to study is Thomson model, or it is also called as watermelon model or the plum pudding model. So according to this model, electrons are embedded in positively charged mass, which is distributed uniformly through the atomic sphere. And this model was proposed by Joseph James Thomson in the year 1897, and it is also called as apple pie model. This model is also called as apple pie model. Next one is Rutherford's model or planetary model. So based on some of the experiments conducted by Rutherford, he gave the planetary model. According to this model, all positively charged particles are present in the small sphere in the center of the atom, which is called as nucleus. And the electrons revolve around the nucleus just as the planets revolve around the sun. Due to this similarity, Rutherford's model is called planetary model or the solar model. Just as the 8 planets revolve around the sun in the path, he compared the planetary model, the electron structure, to electrons which were revolving around the atoms were compared to the planets which are revolving around the sun. That is why it is called as solar model or planetary model. Next one is the electrons. These will be negatively charged, revolve around the nucleus in orbits with high speed to overcome the electrostatic force of attraction between positively charged particles which are present inside the nucleus. So this will be the diagrammatic representation of Rutherford's model or the planetary model. But this atomic theory given by Rutherford, it has two cons or the two deficiencies. First one is, it is possible to have infinite number of orbits. In practice, it is not the case. Means practically it is not possible to have infinite number of orbits. Second one is, the moving electron must continuously lose energy and fall into the nucleus. Actually, it is not the case, because as the electron moves in a circular orbit, that is revolves in the orbit, it has to lose its energy continuously and fall into the nucleus. But in actual practice, it is not possible. So these are the two deficiencies of this model. Next one is Bohr's atomic model, which was given by Niels Bohr in 1913. This theory also has some of the observations. First one is, atom consists of heavy positively charged nucleus. So the whole mass of this atom is situated or concentrated in the nucleus. The electrons in an atom revolve around the nucleus in definite circular paths called orbits or energy levels, and this each energy level, it is having definite amount of energy. So this change in energy takes place when electrons jump from one energy level to another energy level. These are the observations made by Niels Bohr atomic theory. So how the arrangement of electrons takes place in the atom is, in the various shells of an atom, this arrangement we call it as electronic configuration. So the maximum number of electrons that could be put in a particular shell, it was given by Bohr and Bury. That is why it is called as Bohr and Bury scheme. So how the electron arrangement takes place is, maximum number of electrons that can be accommodated in an energy level is given by 2n square, where n equal to 1, 2, 3, 4 and so on. Okay. For k it will be 1, L, 2, 3, m, 4, n. Likewise, the maximum number of electrons in the outermost orbit will always be 8 electrons, even if it has capacity to accommodate more electrons, but the maximum number of electrons in the outermost orbit will be always 8. And these electrons are not accommodated in a given shell unless the shells are filled. That is, stepwise filling of shells is followed. So this is about the electronic configuration. More details about the electronic configuration you'll study in your chemistry classes. Next one is valency. Valency is nothing but the number of electrons which are present in the outermost shell of an atom. That is called as valence electrons. Okay. So these electrons, they are going to determine the valency. So let us take one example here. Okay. So there are no examples. So valency is equal to number of electrons. In case the number of valence electrons is close to its full capacity. For example, if you are having any one of the atom named helium. Okay, helium is 2. So helium is having 2 electrons. We are going to write its electronic configuration as 1s2. Same way, lithium 3, we are having the electronic configuration 1s2, 2s1. So here 2s1 will be the valence electron. Number of valence electrons in the outermost shell of an atom will be 1 for lithium. This is how we are going to calculate the valency. So valency is also called as the combining capacity of the atom. Next one is atomic number, which is represented by the letter Z, capital letter Z. So atomic number of an element is equal to number of protons present in the nucleus of an atom. So here mass number is another concept. It is nothing but total number of neutrons and protons. Sum of protons and neutrons, it is collectively called as mass number. Isotopes, the atoms of the same element having same atomic number but different mass numbers. These are known as isotopes. For example, chlorine. Here, these atoms of chlorine are having same atomic number 17, but their mass numbers are different here, 35 and 36. Similarly, carbon. So what are these applications of isotopes? Where these are used? These are used in the nuclear reactor, fuel, or as a fuel in the nuclear reactor, and cobalt isotope is used in the treatment of cancer. Isotope of iodine is used in the treatment of goiter. So there are many other applications you can find out. At least you have to know 5 applications of isotopes. Next one is the isobars, atoms of different elements having same mass numbers. For example, krypton 40 and argon 40. Here the atoms, they are of different elements. Okay, they are having same mass number. Here the mass number is 40 for both of them. So these type of elements which are having different mass numbers, atoms of different elements which are having same mass numbers, we call them as isobars. So this is all about the brief revision of the class 9 structure of atom chapter. In the next video, we are going to again brief up with the next chapter of any of the classes, either 8th, 9th or 10th, which will be helpful for Hstr, Gpstr and also Karnataka TET or any other CTET exams. So if you like the video, please press the like button and subscribe to our channel